Hey everybody, I hope you had an awesome weekend and I hope that your test went well on Friday. We'll go over that when I get back. So now we're starting chapter 2, and this section we're looking at even and odd functions. So an even function is symmetric to the y-axis. So our definition is for each point xy on the graph, the opposite of xy is also on the graph. This is what makes it symmetric to the y-axis. So say like a parabola. If you had the point 3, 2 on this graph, and we know that it's an even function, then -3, 2 would also be on our graph, on our function. So what we're going to check is, as we do these problems, we're going to see if f of -x equals f of x. If these come out to be equivalent, then we'll be able to say that it's an even function. So let's check number 1. So our function is x squared. We want to see if it's even or not. So remember, we're checking f of -x equals f of x. That's what we want to know if it's going to work. So anywhere there's an x, I'm using opposite of x. So we have -x squared. That equals just the plain old f of x function, which is x squared. Obviously, a -x squared is equivalent to x squared. So now we see that we have x squared equals x squared. Since they did come out to be equivalent, this is an even function. Number 2, same thing. We're checking. Does f of -x equal f of x? All right, so we have 4 -x squared minus -x, and we want to see if that equals the original function. So again, -x squared is going to be just a x squared, so 4x squared minus a negative becomes plus x. Now you can see these look really similar, but here we have a plus x and on the other side we have a minus x. So these are not equal, so this is not even. All right, we'll do the last one here. So again, we're checking, does f of -x equal f of x? So we have -x to the 2/3. Does that equal x to the 2/3? So remember, with your exponents, when we have a fraction, the denominator is the root. So this is actually the cube root, and the numerator is the exponent. So we can rewrite it this way. So again, over here, the denominator is the root, the numerator is the exponent. So on the left, -x squared is the same as x squared. So these do come out to be equal, so this is an even function. Awesome. All right, so next we have an odd function. So this is different. This is symmetric to the origin, whereas the even functions were symmetric to the y-axis. So our definition for the odd function, for each point xy on our graph, the opposite of x and the opposite of y is also on the graph. So if we have a function that looks like this, this would be symmetric to the origin. So for example, if we have a function like where the point 5, 1 is on the graph, then the point -5, -1 is also on our graph. That's what's going to make it an odd function, symmetric to the origin. So what we're checking for these is we're checking to see if f of negative x equals the opposite of the function, so negative f of x. All right, so if we look at number 1, we're trying to see, does f of negative x equal negative f of x? So on the left, we have negative x cubed minus 4 negative x equals. This is the opposite of the whole function. So now let's simplify a little bit. A negative x cubed will remain a negative x, because we can take a negative cubed and still have it come out to be a negative. Then we have negative 4, negative x, so this is a positive 4x. On the right, that negative distributes, so negative x cubed plus 4x. These do come out to be equivalent, so this is an odd function. All right, great. I'm going to erase just to get some more room. So for number 2, again, we're checking, does f of negative x equal the opposite of f of x? So we have negative x to the 5th minus 3 negative x cubed plus 2. Does this equal the opposite of this function? Okay, let's simplify. So a negative x to the 5th will remain a negative x. So any of your exponents that are odd, they're going to remain negative. So again, here's a negative x to the 3rd power, so that's an odd power, so this is also going to stay negative. So that's a negative x cubed with a negative 3. So this becomes positive 3x cubed plus 2. And then over here, we distribute the negative. So these look very similar, except there's a small difference. We have a plus 2 on the left and a minus 2 on the right. These are not the same, so this is not an odd function. Okay, the last one, I'm going to erase again just to give myself some more room. Okay, so again, we are checking, does f of negative x equal the opposite of the function? So on the left we have 1/2 negative x cubed minus 6 times negative x. Does that equal the opposite of our function? Okay, let's simplify. Negative x cubed, it's an odd exponent, so that's going to stay negative. So we have a negative 1/2 x cubed. We have a plus 6x. Over here, we distribute the negative. And it looks like these came out to be equivalent, so this is an odd function. Great. All right. On the back, we're going to start to look at positive and negative intervals of our function. And we're going to be using interval notation. All right, so our positive intervals are the x values for which y is positive. So this means we're going to be above the x-axis if y is going to be positive. So that's sort of visually what you're looking for, where your graph is above the x-axis, which means your negative intervals are the x values for which y is negative, which means our graph is below the x-axis if our y values are negative. Okay, so when we're looking at this graph, so at -2 is where our graph shifts from being below the x-axis to above. So starting with -2, my graph is above the x-axis. and then at -2 to the left, I'm below. Now notice it's asking for positive and negative, which means it's asking where is the function strictly above 0, where is the function strictly below 0. So it's not including 0. So when you're doing your interval notation, you are going to have the open bracket. So it's positive starting at -2 and going to infinity. It's negative from -infinity to -2. So again, open brackets because we're not including 0 here. Okay, let's try the next two. Notice the difference here. Now they're asking us for f of x greater than or equal to 0. So we are including 0 in this one. So let's look at the positives first. So it looks like I'm positive here and here. So we're above the x-axis. And then we are below here in red, here, and here. Now, we are including zeros for this because it's greater than or equal to 0, less than or equal to 0. So for our positives, we are using the closed bracket to include 0. So we are above the x-axis from -6 to -2 and 2 to 8. That's where we're above. We are below from -infinity to -6, closed bracket because we're including 0. We are also below the x-axis from -2 to 2 and 6 to infinity. Cool, one more. So here, they just say positive and negative, so that means f is strictly greater than 0, and then the function is strictly less than 0, so we are not including 0 this time. So it looks like we're positive here, we're positive here, and then otherwise we are below the x-axis. So it looks like positive, so -infinity to -9. Open bracket, we're not including 0 this time. We're also above the x-axis from -3 to 3. And then we're below the x-axis, -9 to -3, open brackets. And then we're below from 3 to infinity. All right, awesome guys. You may start your homework either with your book or you may use your phones to get onto Moodle. I will be here tomorrow, so good luck and I'll see you soon.